So if you're viewing this video, it's because you are looking at the slides from 5.5 and 2, and you're told to see me. So we're going to talk through how to do orbital notation and electron configuration notation. But to do that, we have to go back and review a couple of things that we've previously talked about. The first thing that we have to go back and talk about is we talked about the 4 different quantum numbers, and we kind of brushed upon them, but what I want to highlight is that how that affects the electron configuration or orbital notation. The first thing I want to point out is that every energy level has a very specific number of sublevels and a specific number of sublevel types. So for example, in the first energy level, there is one sublevel, and that one sublevel is S-shaped. The S shape is spherical in nature. It can hold 2 electrons total. The second energy level has 2 sublevels, the S and the P. So it has an S-shaped sublevel and it has P-shaped sublevel that has 3 orbitals in 3 different directions. And each of those orbitals in different directions can hold 2, 2, and 2 electrons for a total of 6. And then we have the third energy level, which has 3 sublevels, the S, the P, and the D, which means it has an S sublevel, the P, the P, the P sublevel, and the D, the D, the D, the D, the D sublevel. And in this case, the D sublevel has 5 different orbitals in 5 different directions, each holding 2, 2, 2, 2, 2 electrons for a total of 10. Okay, so that brings me up to another part of the notes that you had taken where you saw something about orbital notation. So an orbital notation is a way for us to visualize where a specific electron is around the nucleus of the atom. The first energy level is represented by 1, the second energy level is represented by 2, and the third energy level is represented by a 3. Okay? This S is the only sublevel the first energy level can have. This S and the P, the P, the P are the 2 sublevels that the second energy level can have, and this is a partial third energy level. Each arrow here represents 1 specific electron. Another thing that we spoke about was this, where we have 1s2, 2s2, 2p6, 3s2, where the 1 is the energy level, and the S is the sublevel, the 2 and the 2 is the second energy level, and the S and the P are the sublevel, and the 3 here is a partial energy level with one of the 3 sublevels it can have. These raised 2, 2, 6, and 2 are the number of electrons that are present in that particular atom. So we also have another way to help us learn how to do this skill with this visual. And the visual is that here's each color scheme is a different energy level. So the red one here is my first energy level. It has 1 sublevel that can hold 2 electrons. The orange here is the second energy level. It has an energy level that is an orbital is an S that can hold 2 electrons, and 1, 2, and P, 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 each can hold 2 electrons. And then here's my third energy level. We're going to talk about how this gets a little bit more complex on another day, but we have our S sublevel, our P, P, P sublevel, and our D, 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 D sublevel, each holding 2 electrons all the way through. Which finally gets us back to, we'll talk about that in a second. Which finally gets us back to how we write our electron configurations and orbital notations. So here we have boron. Boron has an atomic number of 5, a mass number of 11, so that means it has 5 protons, 6 neutrons, and 5 electrons. So if we come back to this visual right here, okay, we can see that in the first energy level, the 1s energy level, first energy level has an S sublevel. So I can write that as 1s, and I'm going to add the number of electrons that it can have in it represented by arrows. So I'm going to go arrow up and arrow down, and now I've used 2 of the 5 electrons for boron. So then I'm going to move up to the second energy level, and I'm going to write out the 2s sublevel, and I'm going to write out the 2p sublevel and break it apart into 2p, 2p, 2p. okay? So now boron has 5 total electrons, so I've used 2, so in the 2s sublevel, I'm going to go arrow up, arrow down. Now I have 1 electron left, and I'm going to put it into the 2p, so it's going to go arrow up. So I've got 1, 2, 3, 4, 5 electrons for boron placed in the 1s, 2s, and 2p regions around the nucleus of the atom. So this is what we call the orbital notation. The electron configuration notation takes all of this into consideration, is a little bit more general. What I mean by that is I can look at this and say 1s2, 2s2, 2p, and this is going to condense into 2p1. So this is a little bit more specific because I could say, well, if I'm really focusing on this particular electron here, I know where it is exactly, but with the larger the sublevels, it becomes a little bit more vague. So this is how I'd write the electron configuration and the orbital notation for boron, which now brings me to the last slide, which is slide number 9, which we're talking about nitrogen. So nitrogen is an element that has an atomic number of 7 and a mass number of 14, which means it has 7 protons, 7 neutrons, and 7 electrons. So every time we write an orbital notation and an electron configuration, we're only concerned about the electrons for initially, and then the other thing that we're concerned about is we always start at the same spot. So we always start at the first energy level, which means I'm going to always start with 1s, and I know that my S shape can hold 2 electrons, so arrow up, arrow down. Then we go from 1s to the second energy level, which has 2s, and it has 2p. 2p, 2p, 2p. Okay, so 2s, 2p, 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 represented over here. So on my 2s, I can only have 2 electrons, so I'm going to go arrow up, arrow down. And on my 2p, I have to figure out what to do with the rest of my electrons. So I've used 1, 2, 3, 4 electrons of the 7, which means I have 3 more to find a place for, which brings me up to this slide right here in the notes. When we're doing this, we're always assuming that there's no extra energy added to the electrons. We are always starting with the energy level closest to the nucleus, so the first energy level. We are always making sure that no 2 electrons have the same quantum numbers, so that's why when we're drawing them, we go arrow up, arrow down, and that's how we keep them separated. And then the last one says separate the electrons into separate orbitals in the same energy level. What I mean by that is that if I have electrons to place and I have PPP, I won't go arrow up, arrow down, arrow up. I will go arrow up, arrow up, arrow up first, and then go back and do arrow down if necessary. So that means that this is the correct electron or orbital notation for nitrogen. If I go to translate that into an electron configuration for nitrogen, it becomes 1s2, 2s2, and again, this would condense to 2p3. Now, if by chance I had an atom that had, let's say, 8 electrons, this would look a little bit different. It would look 1s, arrow up, arrow down, 2s, arrow up, arrow down, 2p, 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 arrow up, arrow up, arrow up, and then finally arrow down. Okay, so we always go up, up, up before we double them up and go down. I think that kind of sums everything up for the lesson for U5.5 and 2. Again, if you have any questions, please come talk to me.